Hey everyone, welcome to Microservice 101. I'm sure you all have heard of the microservice architecture. By definition, it's a practice of breaking up an application into smaller and more specialized parts. These parts communicate with another across common interface such as APIs and HTTP. Unlike the monolith architecture where everything is in one place and there's often only one centralized database, microservice can consist of multiple servers with multiple databases working together. Here's a very good analogy of a monolith architecture versus a microservice one. You can pause the video and read it when then we will move on to the next section where I explain the application that we'll be breaking down. Let's move on to the next part. Next part is going to be about the application that we'll be breaking down and its architecture. So first, I want to say a disclaimer. Microservices is an extremely flexible architecture, so the way I'm implementing it is just one of many ways to build this application. I'm sure that there are many better ways, and also with an application of this size, using a monolith would have been better. Um, here's the here's the application. It's called Simple C. Where's my cursor? It's called Simple C, and that stands for Simple Calendar. So the main functionalities of this app is that it lets you create a to-do list, and then you can add the to-do item into the current date in the calendar. So here's the demo. This is the authentication part. I'm just gonna sign up. Uh, Name, yeah, it's gonna be whatever. Debt free at simpleC.com 1, 2, 3, 4, 5, 6. Here's a little sneak peek of the log. So I have already had the microservice running here. Let's do OK. Uh, OK. Now I'm gonna log in. Simple C. There we go. Um, Now I'm gonna add a to-do item. Walk the Dodge. Um, OK. So I just created a to-do item. Now I want to add it to my to-do list for today. So I'm gonna do add to calendar, and here we go. It's there. So that's the application. It's very simple, just for demo purposes. Um, so this is the architecture of the application before we break it down into smaller pieces. So we have the Node.js server that serves the bundle React application, and the server also handles all the API. Um, it talks to the one centralized Mongo database that stores three tables: the user table, the to-do table, and the event table. Um, so how do we split this application? So this decision mostly depends on business constraints, but since this is just a demo and I'm free to do whatever I want, I'm just gonna split it into three obvious parts. Uh, the main web application that serves the React application, the React bundle, and stores the user information in Mongo and also handles authentication. So that's the web app right here. Um, and then we have a node server that handles everything related to the to-do list. And we have another service that a node server that handles everything related to the calendar service. Um, so this is the diagram right here. So with this new diagram in mind, in the next section, we're gonna talk about how we are going to break all of this down. Now, before we do anything, let's get familiar with the original code base. So this one is a very simple application. Here we have a Node.js server that serves the React bundle. The server handles all the API like the events API, the auth API, and the to-dos API. It talks to one single Mongo database, which is hosted on the cloud. Most most of the APIs require authentication except signing up and logging in. Um, the auth middleware here that I have is responsible for handling authorization. It basically uses the secret to verify if the token is legit and then saves the user ID into an intermediate data store that can be later be used to fetch personal data. As you can see here in the events API, um, the auth middleware is used to authorize the request as well as getting the user ID from the token to fetch the events that belong to the users who make the request. That is this line right here, and that's it for the application. Very plain and simple. Now let's talk about breaking all this down. First, we need to talk about authentication, then authorization. How do we implement this when we break everything apart? This part had given me a lot of trouble and confusion until I talked to Ben Vitali when he suggests that I should just let the server that serves the UI handles it. So here we have the web app service responsible for just authorization and authentication, which basically means logging the user in and giving them a JWT token. Since all the applications share the same JWT secret, like you can see here, every one of them is using the simple secret. Um, the calendar on the to-do list service can verify the token and then authorize the user to use its service. Here's so and from decoding the JWT token, all of the service can get the user ID and then they will know how to look up the to-do list or the events of this user. Here's a little demo of how this works out. Let's log in again. Remember that free at simplec.com. 1, 2, 3, 4, 5, 6. Pay attention to the network tab that I have right here. So here after logging in, the client will receive a authentication token. Let's copy that. Um, if you decode this token, it will show the user ID as such. Remember this 89D. Now with this token, the calendar service will use their secret to verify that the token is legit and then use the user ID to look up the user table. Here we have one event returned from this request, and in this event, the user here matches the user ID that we just decode, which means that the event does indeed belong to the person who makes the request. Now, before we move on to the second point, let's just create the two new services according to the diagram. First, we are going to create the two new folders that represent the two additional services, the calendar server and the to-do server. Ignore the search server here. I'm gonna use that later. Now, in each of these new folders, I'm gonna copy the according functionalities of the main app entities. So you can see here, the calendar server serves the events serve only the event API compared to the monolith one that serves all four APIs. I also copy the event model over since and I don't copy the to-do model, the to-do APIs or the auth and everything like that, since the calendar service doesn't need to know about any of these things. Um, I'll be let's also copy the auth middleware and the secret over. Um, I be doing the same thing to the to-do one. Now you can comment out or delete anything that relates to events and to-dos in the web app. Remember that the web app service, in terms of API, only needs to handle authentication and storing users' information. Um, Now, if I just leave it at this in terms of the number of services, it will work okay, but it will be also very chaotic for the client developer, or specifically the people who work on the React application. The people who work on the client will have to remember which endpoint or service to call instead of just calling slash API slash events or slash API slash to-dos. For example, if they want to call the calendar service to fetch all events, they will have to specify like HTTP calendar service 5000 slash API slash events. These problems can lead to decreased productivity and also increased complexity for no reason. So the way I deal with this is to use a reverse proxy. Let's look at the diagram again. Um, here the nginx reverse proxy stands between the client and all of the other backend services. What the reverse proxy does is it redirects requests to the right place depending on the location that we specify. Here's my nginx config file. What it says is when the user requests something at slash like localhost 5000 slash, we are going to fetch the generated React bundle or the web app frontend. If the user requests the auth API, we redirect the request back to the web app backend to handle. If the user requests the events API, we redirect the request back to the calendar service to do its job, so on and so forth. Now the developers who work on this only have to call slash API slash auth or slash API slash events, and they don't have to worry about the base URL. Now with all of this setup, what we need to do is to containerize these services. All you need to do for this step is to create a Docker file for each service. This file will tell Docker um, how to build an image for a particular service. This image will come in handy later when we use Docker Compose to run multiple containers that talk to each other. Here's my Docker file for the calendar service. Basically, um, basically what it does is it tells Docker to fire up a node container. In this container, we are going to copy the content of this calendar server folder into the source folder of the node container. Then we run npm install to install all of the dependency, and lastly executed it with the command npm start. The expose command is here just to remind us that the port that the node container will expose is 5000. This will come in later when we set up our Docker Compose file. We have the same thing with the to-do service. Uh, Now for the web app service, it's a little bit more complex since we also have to bundle up the React application inside. So here, same step up here, but here I have to change directory into the client folder and run npm install. Then I will have to change directory in the client one more time and do npm run build to generate the bundle. And the rest is self-explanatory. And we are almost done. The last part that we have to do is to have all of these containers run in a specific order and to have a persistent store for them. So in case a service goes down, the data does not go away with it. This is where Docker Compose comes in. Here's my Docker Compose file. First, I specify my web app service. Here's the folder that Docker should come and look for the Docker file. And the application will expose the port 3000 to my localhost, and port 5000 is where the node container expose the application inside the network. Same thing for the to-do service, except that I have a MongoDB URI environment here that tells the service to come look for Mongo server at this address. Down below is an actual Mongo server. Pay attention to the volumes config. This config specifies where the data will be stored. In this case, the data will be stored in a volume called data volume. Same thing for the calendar service. Um, and the calendar database. Ignore the searcher service again. Now comes the nginx config. This thing is actually what talks to the users. Um, Same thing here. I expose the port 5000. So when I go to localhost 5000, the whole application comes together. In volumes, the first line specified that Docker will bind the web apps client build folder to the static folder of the nginx service. This is so that nginx could actually serve the generated bundle and the HTML file. The next line tells Docker to wait for all of these servers to fire up before running nginx. The reason for it is if we don't wait for web app service to fire up first, and then we don't have a static file to serve. If we don't wait for the calendar service and the to-do service to fire up, then there will be no data to fetch. There will be nothing that the user can see, even if we have the web app up. Lastly is the volumes config. This simply just tells Docker to create a persistent volume called data volume in the host machine. So once the container goes down, all of the data still persists inside the storage. Now that's enough talk. Let's actually try to run the whole thing in my local machine. So here, let's go back to my terminal. Right now, I have my server running right here, and you can see the log, everything. I'm gonna kill this all of these containers by doing Control C. Right now, it's stopping the container. Just wait a moment. It takes a little bit of time to do that. I'm gonna do Docker Compose down. This way, when I do this, all of the things that everything that related to this Docker Compose file will be deleted. Um, they will delete the container. They will stop the containers. They will delete the network. They will delete the volumes. Let's do that. So right now I'm at the blank state. Nothing is my server is not working right now. So let's go to localhost 5000. This side can be reached as I expected. Now what I'm gonna do is docker compose up again. It will run everything, create all the service. Now let's try localhost 5000. Fall 3 forbidden. The reason for this is because my machine, the host machine, which is my machine, doesn't let nginx reads from my data volume. So this is kind of an extraordinary step we have to take. So what I have to do is to first see what the nginx containers image is, the container ID is, which is this one. What I'm going to do is I'm going to run the bash, run a shell in this container, docker exec dot it and sh. Uh, I'll do ls, and there's the server. There's a srv folder right here that I have to chmod. I'll do chmod 644 star. Okay. Oh, sorry, I have to cd in here first. C4 and chmod 6. I suppose doesn't make a difference. Exit. Localhost 5000. Let's do that again. There we go. We back. Let's try sign up. Why not? Sign me up. Dev10 simplec.com 13456. Okay. Dev10 simplec.com 13456. Go back to the log here. Log in. Let's do add to do item. Work my docs. Okay. So it adds the log. Okay, everything is working okay. Let's add to calendar. There we go. Everything's working. So that's it. It's kind of simple, but not really. Uh, but if you this one is very this architecture is it's very interesting. So when I start learning this, I have a lot of questions. So if you and I still do. So if you have any questions, just fire it at me. Just give me questions. I'd love to answer them. Um, I will um, I will give you guys a link to my to both of my repos soon. So this one is on. So this one is the original monolith, and this one is the simple C microservice demo that I just commit. Those are the two repo that I use. Like I said, if you have any questions, just direct it at me. I'll try to answer any of your questions. And if you have anything that you can add to my video, like what I did wrong and what I should improve on, feel free to shoot me a message on Slack. Thank you very much for listening.